In this video, I'm going to explain just-in-time compiler. We used to come across this term frequently whenever we are talking about performance about JVM. JVM is Java Virtual Machine. JVM has two main components. One is interpreter and another one is compiler. So before going into the details of JVM components like compiler and interpreter, so let us start this with small program, writing a small Java program. So this is a small Java program. It is a straightforward program. So where we are printing one string and one more string and then one more value. Dynamically, it is taking that variable value in a loop. So that means, so this value, I value is being printed 5 times. So without running this program, we can expect the output of this also by just by saying what is the output of this program. So now when we'll save this program, we'll be saving this as a.java. Now a.java, when it is compiled using Java C, you'll be getting a.class. So this is the Java compiler. Java compiler will convert a.java to a.class. So this is the bytecode. We say bytecode. This Java compiler is outside the JVM. It is outside the JVM. Now once a.class is submitted to JVM, So how it is submitted to JVM? When Java command is executed. So then JVM is launched. And now JVM has a component called class loader. So class loader will load this .class file into the memory. So .class will be loaded in memory. Now JVM has a component called interpreter. Now interpreter, what it will do is, so it will read each instruction in the bytecode format, which is in .class file, where the .class file is loaded in memory. So it will read each instruction, convert to machine code, machine understandable code, where that machine understandable code is submitted to processor, and processor is, here we say microprocessor. So microprocessor will execute that machine understandable code and gives the result. So interpreter will read each instruction, convert that to machine code, and the machine code is executed by processor. So this is the overall summary that interpreter is doing. So actually what this .class file will have is, so if you see in bytecode instruction format, so on a summary we can understand it has these instructions: print hello, print how, next is repeat this instruction, five times. What is that instruction? Print I value. So this is how the instructions will be there. I mean, just for our understanding. So this is the class file which contains these instructions, and this is loaded in memory. Now JVM interpreter will read each instruction, convert that to machine code, and submits to the microprocessor. So microprocessor will execute that instruction. So now we will see how much time interpreter is taking to interpret all these instructions. So interpreter function is it will read instruction one by one. So first it reads this instruction and then it will convert to machine code and submits to processor. So for all this it takes 3 nanoseconds, for example. Now again interpreter will come back to the memory where the class file is residing. Again it will read the second instruction, convert that to machine code and then submits to processor. So it is 3 nanoseconds, the second instruction. Now third instruction is a loop. So it will convert third instruction, print I value, again to machine code. Again it submits to processor. Again it comes back to the memory. Again it will convert the same instruction again another time. Now again it submits to memory processor, the machine code which is being which has been converted from the bytecode instruction. So like that, this instruction is being converted 5 times. So every time JVM interpreter will read this instruction, convert to machine code. So like that, it will take 5 times. So it will read for 5 times. So total for one iteration, it will take 3 nanoseconds. Total, it will take 15 nanoseconds. Now the total time is 15 plus 3, 18, 18 plus 3, 21 nanoseconds. Now here comes the another component of JVM, which is compiler. So this compiler and this compiler are different. So this Java compiler, which is before converting to .class file, that is actually part of JDK, Java Development Kit. So it is outside the JVM. Now JVM has again its own compiler, which is called just-in-time compiler. This is called just-in-time compiler. So our video is mainly to explain this function of just-in-time compiler. Now JVM has an intelligence. So whenever the same instruction is being executed or is being converted to machine code multiple times, so that instruction it gives it to compiler, just-in-time compiler. So in our program, the third instruction is the one print I value is the one which is being executed multiple times. So now this instruction it will give to just-in-time compiler. So what just-in-time compiler will do is, so it will convert that instruction one time to machine code and it will allocate a block of memory and it will store that machine code instruction into that block of memory. Now the processor will read that block and executes for as many times that instruction is being given. So that means here what is happening is, so just-in-time compiler so will convert this instruction print I value to a machine code understand format and stores in a block of memory. Now processor will read that instruction and executes that for 5 times. So that means here what is happening is the conversion to machine code, the repetition of the conversion to machine code of the same instruction is being avoided. So that means, so one time it is being converted, the other times the processor will execute that instruction multiple times. So in this way, we can see now when JIT comes into picture, what is the total time of execution of this program? Now the first instruction is not a repeatable instruction, so this is being executed as usual. So this will take 3 nanoseconds. 3 nanoseconds. So this will take 3 nanoseconds. Even the second instruction is also interpreter. The third instruction will be taken by JIT. JVM will delegate this instruction to compiler, JIT, just-in-time compiler. Now the third instruction this instruction will convert to machine code and this will store in some block of memory. So for that it takes 3 nanoseconds. Now processor will read this instruction and now what is the total time now taken by the JVM now is 3 plus 3 6, 6 plus 3 9 nanoseconds. So that means just-in-time compiler will is avoiding actually converting the same repeated instruction to machine code multiple times, and it is converting only for one time, and thereby the processor is executing that same instruction multiple times. So in this way, just-in-time compiler is boosting the performance of JVM.